Hello and welcome to the world of NDE 4.0. My name is Johannes Rana, and today I have a really special video for you. And with me today, I have Ripi. You all know him, but Ripi, perhaps you can say a couple of words about yourself.
Good morning, good afternoon, good evening, wherever in the world you may be today. Thank you, Johannes, for having me here, along with the personality, Daniel Kanzler. So my name, Ripi Singh, once again, former professor of engineering, former executive in technology companies, and now practicing innovation coaching for the last 10 years. 6 of that have gone with Johannes Rana on Industry 4.0 applications. Thank you, Johannes, for having me here.
And even more important today is our special guest, Daniel Kanzler. Daniel, he is I think, very well-known expert on probability of detection, on POD. And what perhaps not that many people know, he is at the moment my employee. And he was awarded this year for his work on POD. So what better opportunity than to have him as a special guest here with us today. So today, and I will invite Daniel to say a couple of more words later, we will first get a presentation from Daniel on POD, and then Ripi, me, and Daniel, we will discuss about his presentation. So Daniel, now the stage is yours. Perhaps you can use a few more words to introduce all of us to you.
Thank you. Yeah, thank you also to be here, and it is a magnificent possibility to tell the world a little bit more about like reliability and in specific POD. So this topic, well, I started it around 15 years ago. At that time, the first ideas I had an industrial company, GE, General Electrics, right now, I think it is called differently. I think it is Waygate. At that time, it was still, I think, Neutronic. I'm not 100% sure. So yeah, well, a lot of changes. However, after that work, I did there my diploma thesis on ROC curves, receiver operating characteristics. After that, master degree about my first steps in POD. And then I changed to the Bundesanstalt für Materialforschung und Prüfung, BAM, in Berlin. And I met Christina Müller, which was my boss for around 6 years. Ripi knows her also very well, and knew her very well because after I left, very short time after that, she died, and she is really missed in this community. However, at that time, I took the topic in my own hands, and I want to bring it back in the industrial field. And well, this year, I think I kind of managed it because I want to show it to you right now. So if you are okay, I would start with talking about the perfect. So yes, we got this year the application award for that title, and normally there are 2 people sitting here. One, Nico Lehmann from Porsche Leipzig. However, because we don't have too much time, we want to focus more on the topic on POD. So I will take a little bit the part of the testing equipment with me and go more deeper into the POD. So the idea is to have an industrial suited NDE 4.0 approach, a validation of automated ultrasonic testing applications. And for that, we're using the POD. And in a very specific kind of way, we do it directly on the production floor. And how to go there? Well, I want to give you kind of an idea, show you how the process is working, etc. Right now, you see at the first slide, you see the surrounding of the Porsche Leipzig GmbH production floor, where they build, and in this specific case, test the car bodies, and their issues, etc. I want to talk about today. So a short agenda. I will explain you a little bit like the state of the art, what is done right now, or before we started with the project. Then I will shortly talk about the non-destructive automated testing for the car body. I give you a short introduction on POD, just in the case you're not so familiar with it, what we changed to use it here. And as the final, I think this is a reason why we got the award, a kind of idea of a real-time POD on the production floor. So you see the component we are testing right on the right lower corner. This is a car body, a specific car body of a car. I think a few of us would love to drive or even to have. It's this one is a Macan Porsche, and for that one to hold the structural integrity together, they have the resistant spot welding. So you don't have a line, but you have different spots. A lot of them. It's like 5,000 each car. And right in the moment, even when we are talking a lot about gluing, etc., still 70% of the connections in the car body are done by the spot welding. For the spot welding, you have different possibilities how to see if the quality is correct. I just give you an overview about the matrix. In our specific case, I will talk about the lens diameter, even when I simplify it a little bit more. So whenever I talk about the spot weld, it is like the diameter, as you can see on the pictures. This is what we are interested in. And the interesting part is we can do that with ultrasonic, and we can also do it with metallography to cut it open and to see the real value. Both of them are quite important, especially when you know a little bit about POD. You will see why. Right now, the let's say golden standard in quality testing is an imaging ultrasonic testing method. So you have a picture, you have an objective result. This is great. However, you need to have a couplant. This is quite annoying in the case when you have different materials like aluminum and steel, etc. And the testing time is 25 seconds around for one spot weld. Well, if you have 5,000 of them, each car, well, you get an idea of how many of them you might test. So this is kind of the state of the art. Then a few years ago, they tried to think in a completely different way, in an automated NDT system, just to get the amount of testing higher. And the question is, how good are we? This slide is quite interesting in the moment, because it is, on the one hand, it is the project history. However, right now it's generalized, and it will be written down in a standard, in a VDA standard 236-170, which will publish probably end of the year. So this will be a kind of standardized procedure how to qualify your NDT system. So in the first phase, we had like the principle suitability. Is the testing system adequate in what we are doing? The next one is a concept suitability. You see it on the picture. We have the first components, realistic components. You have the first time a robot. We did there the experiments on in Vienna. In the next step, we have the first pilot testing system, which is right now in Leipzig. So you have the full car body, and not anymore the small robot, but the huge robot. And there, of course, we start with the validation. We start to think in the direction of POD. And in the end, and this is right now the time, it is the capability of just looking on the product floor to see it while it is in line, to have the validation. And this is, of course, then also quite nice visualized here with a program called Sounds. I will also talk with that about that a little bit later. Here, a few pictures, a short video on how it is done right now. So you see the big robot. You see the first parts, which are right now on this yellow kind of holding system. You see here the testing system, the new testing system, which is calibrated with the huge robot going to different parts right now, to different spots, testing them. Then you see here, for example, also how it is done, like in more detail. You see the round little spots. They are the welding spots. And the green is, well, it is a laser system, a laser acoustic system. Through that testing, it is quite possible to use it on very small areas. Through that time, the testing, the probe was changing in different variances. This is where you have like the German slide on the corner. Yes. So the amount of spots, how to test them, they're quite easily right now to reach. And with the robot, it is quite fast. So with that, the whole kind of amount of testing is raised really high. And here you see the golden standard. So the person is right now checking a few of them to see, okay, what are the results in the imaging, ultrasonic testing. You see there the kind of C image of the ultrasonic testing system. And that one we will also talk about. So this is a little bit to give you an idea about the real industrial application, that I am not talking about some scientific, well, let's say, I don't want to say nonsense, but a scientific level, but a really shop floor level. And so right now we get a little bit more deeper into POD. And for that one, I think it makes quite a lot of sense to look a little bit back, like around 20 years or almost 30 years. At around 30 years, my former boss, Christina Müller, that was even like before my time, she had the great idea to say, well, let's start with a POD and let's put them into standards. And at that time, there was there were like two different ideas of that. And the automotive in this time was completely against it. It was one of the major players, and they were so strongly against it that they stopped it. So at that time, Germany just said, okay, well, we won't do it. So the interesting part for me is right now, 30 years later, I'm standing directly like on the stage with automotive, like side by side, and telling you, okay, that might be probably the correct way. So for me, this is kind of the feeling, one of the ideas which are never dying. So when Nico was coming like 5 years ago to me and said, well, you know, I have that problem. I want to introduce a new testing system. How should we do that? I have a small laboratory, etc. I said, well, you know, I have the perfect solution. It's a POD. So the typical way I did it before, it was not my first POD, so I looked in the typical standards, well, ASTM standards, in the INIX standards, in the MIL handbook. I said, okay, the POD is pretty easy. You have a kind of general relationship between your response of your NDT system. This is called the A hat. I will show you here the A hat. And you have the true defect size like A, and then you have a nice relationship between both. You have a little bit of scattering. Based on the scattering, you do some, let's say, statistical magic. You get that nice curves, in this case, Gaussian distribution. And based on your decision threshold, you can say, well, at that defect size A, we have a probability to detect it 50%, and if we go more upper, then it gets more and more. And based on this idea, we have this wonderful curve. And on this curve, we can do a lot of things. We can see, is it right now here in this area where it goes from low values to high values? How fast is it rising? How good can a testing system here differentiate between different sizes? We can see like some critical characteristic for structural integrity, or A1995, where you have the crossing of 90% POD with a confidence band. The confidence band is also done by statistics, that you have a feeling of how good your evaluation is. Well, you know, it's a perfect curve. However, then he started and explained me a little bit about his spot welding. And the first thing was, he was not really interested in some defects. He was interested in the true size of his spot weld. So if the spot weld is large enough, for him, the weld is okay. If it's too small, then he has an issue. So the first thing is, okay, when we are talking about A as a spot weld, we will probably turn the POD around. Okay. The second thing is, for the laser acoustic technology, I didn't introduce it so strongly because I'm not really an expert in that, but you have an indication, and this indication is very depending on how you do the signal processing. So you can, for example, take like the highest points, etc. You can take a 3 dB drop here or something else. So when we're taking the highest point and you get the idea, this one is much larger than here, then you have an offset. The offset is something in physics that is explainable, okay? But that means A hat might be something larger than A, but it will have something like millimeters on it. Normally, in a typical POD, when you have, for example, ultrasonics, you have dB versus your millimeters. So this is the next thing. Then you have the offset. So I said, okay, maybe we should think that whole POD approach a little bit through. Then I came with the A1995. I said, well, you know, we are not so interested in it because we have something else. We have an DL-min. This is our minimal diameter. This is where we have the difference between this part is okay and it's not okay. So this is like when we sit together for a few hours, we realized, okay, our A hat versus A diagram is completely different to what we had before. So the question is, could we still use the mathematical approaches And is it helpful? I want to explain you there a little bit more about it. So you have the A hat and you have the A. So at the A, you have a critical, you have like, let's say the threshold between it is okay and it is not okay. When you have a decision threshold based on what your testing system is giving you, then you have, well, you won't find everything above it, and you will find that. So this one are our hits. Our defect, our spot welds are too small, so this area, and our testing system is giving us the information, so here. If we have too small test spot welds, but our testing system is saying, well, they are okay, then we have the areas of misses. Beside that, that minimal diameter, we have the area of okay. So which means the spot welds are large enough. Our testing system is giving that large enough. So that is brilliant. That is great. However, here we have the false alarm rate or the false alarms, and we can calculate a rate for that. So the interesting part in that is, on the one hand, we are turning the POD around. On the other hand, we have these 4 kind of fields in one POD. And at the beginning, I had some kind of issues with that, because this is normally something which we don't accept in a normal POD. So the question was, can we do that? And when we had the first data, we said, well, yeah, we can go in this direction. However, we need to specify the cases, and we need to specify that when we compare 2 things with each other, they are done with the same method. Otherwise, it's not usable. And we are not in the complete, very high critical areas like nuclear and aviation, where I might not go directly into that, but you will soon see why it might be okay here. So the interesting part is here, just open your frame, describe your frame, then you might even go with like a more modified approach of POD. So what did we do with that? I showed you before the imaging UT testing, so the golden standard. And you see here the values, you see here the line, you see here, well, that is quite, well, we have here 6, we have here 6. So they don't have an offset. So that looks quite good. At the same time, and this is only one case, but I just used that case to see a little bit the differences. So don't say right now it is all the time like this. It is depending on the sheet deep, the sheet thicknesses, the welding spots itself, etc. But you see here the layer testing, which we introduced, the automated testing, they have this offset, as we explained before. And for me, right now, that is okay, because our decision threshold is also based on an offset. So you see here is a like on light gray. Here we have a threshold. We have here a threshold, and you get 2 different POD curves. You have the upper one, which is the normal POD curve, and the lower one, which is the confidence band, and the same in red. So with that kind of way, it was possible to have 2 completely different testing systems and to compare them with each other and to say, well, okay, at that point, it is right, so good or so good. You see also here, we are not talking about the A1995. Why is it? Because right now we are not going back to like change the structural integrity. We have, in this specific case, we have so many welding spots if one of them might fail, that is not so problematic. If a lot of them are failing, then we have an issue. So the criticality is a little bit lower. Why? It means that we can also accept like lower curves. The interesting, as I said, is around the minimal diameter. If it goes much lower, like there is almost no spotlight, well, then we detect it very well. And in this area where we have large spots, well, it is not really relevant. If it is larger, well, it will hold. So with that kind of approach and the changing of the POD ideas, we came to the first solution. We came to compare two different methods and realize on different components if it is good or not. The interesting part here is we used still the metallographic size. So we cut every of this lot of points. We cut it open, looked in it and said, okay, this is our real true size. But, well, I think if then we were pretty much like finished with the work, but probably this wouldn't be worth an award. So the question was then, can we go in something which is so extreme that nobody did it before with a POD? Can we do a POD in real time, directly in the line, in the series production of a car body? And what I gave you right now are pretty much the ingredients. So we have a statistical characteristic, a new one, which is right now introduced, where we like compared two different methods with each other. The question is right now, if we having, for example, the automated method, what is right now our, let's say, kind of truth? And the interesting part here is we used as a ground truth, in this case, the golden standard. This was why the guy was still looking with the manual probe there and getting the real sizes of the welding spots, and with that one, it goes directly into a database, and within the database, you see it here, like it is a screenshot where all the points which were tested for a specific time, or here it's called today. Well, it was not today, but you know what I mean, or this week. So you have a lot of testing points. You have the direct introduction in a database, and in the database with both information, you get that kind of POD cockpit information, the characteristic. Whenever new data come into the system, you get a new POD, you can show or you can see if it is going in the wrong direction, etc. And this was for us why we said, well, this is kind of worth calling NDE 4.0, because you have right now the connection, you have the data coming automatically into that, you have an evaluation characteristic discussing your method. Of course, it was not work done in 1 or 2 hours, but you saw it was like 4 or 5 years. However, at that time, the interesting part is we learned much more about the testing system itself, about the process, which is right now generalized, the statistical proven innovative NDT method, which is right now running at Leipzig and probably also on other companies. So that was when we were really happy to stand there on the stage and say, well, you got it. You got what we did. And we are so happy to have that award. And hopefully the two people who invited me today have a similar kind of clue about it. But of course, it was not only done by two people, but by a larger project team. There are the names for them. I hope it was kind of interesting for you right now, which maybe gave you a little glimpse into what POD can do, even besides the typical aviation and nuclear power plants, and that this is, an area which will have a future, hopefully.
Daniel, first of all, thanks a lot for your presentation and congratulations once more for the award.
Thank you.
I would like to give Ripi the stage for his first question.
Wow! So once again, Daniel, congratulations. And this is an interesting derivative, offshoot, whatever you want to call about it's POD, the fundamentals behind POD that you have demonstrated. Wonderful. This subject of POD is something that I touched upon from 1999 to about 2002. And that's where I met Christina Muller in 2002 when I came to BAM for a class on POD. And we used to look at all these ROCs and human factors. And I think we deployed design of experiments to quantify human factors in there. And one of the things we learned at that time, and I wonder if that is still true, that you can never really have a zero POD. There's always a certain minimum false calls that show up, and you never really hit 100% POD because no matter how big something is, you could still have some crazy factor that it's in front of you and you still miss to see it. So we used to kind of do that. I wonder if with all the robotic automation that you have seen and installed, that you are actually getting to a point where you can hit 0 on one end and 100 on the other end. Have you seen that, or we are still kind of getting very close to 0 and very close to 100, but there could still be chances that we never hit that? So that's my first question from one of your charts.
There are two answers for that. The first answer is lying in the statistics. So when we are, for example, take some distribution, a Gaussian distribution is never at 0.
Yeah.
It is all the time like going in the direction, but never 0. So when we are using just a normal distribution, our curve is doing this. The question is that the area where we are interested in, or is it more like this area where we want to we want to see like the most of them?
That's a good point. That's a good point. I think that's a good point. As to what's the relevant domain of focus that you are interested in, right? If it is really, it doesn't matter whether it was 0 or near 0. It has very little practical implications, more theoretical.
Exactly.
Good point.
And the second point is what we are doing right now is we are looking at different things. We are looking, for example, at the robot. We are looking sometimes at the human person even. However, in the process, what you are doing, you are all the time kind of filtering. So for us in a specific field, it is quite important to say, is that testing system capable of solving my problem? And at the same time, you still have all this, for example, quality management stuff and people checking, is the testing system really doing that, or is it doing something completely else? So what we offer is a kind of model which is simplifying the real world, but which gives you a clue of in which direction are we going, or is it useful or not?
Oh, I like that. I like that. Thank you very much. Johannes, can I ask another 1 or 2 questions?
Yeah.
I'm all excited about seeing this thing one more time after so many years. Daniel, you mentioned that we no more need to worry about 1995, and I understand that because that comes from, it actually came from US Air Force long ago. Do you still, in the case of automotive sector, look at the 95% confidence bound?
In this case, yes, we do.
Okay.
On the one hand, well, let's say I had no reason to move away from there.
Mm-hmm.
The interesting part is when I had the first discussion with him, with Nico, that was like, yes, we are doing NDT. Of course, we are doing it well, and we are doing it with according to the standards, etc. But in principle, we have no idea how good we are. So if you have then a reference point, then we can start to discussing. But when you have absolutely no reference point, well, then it is really hard to discuss the whole topic.
Yeah.
And I think that is true for a lot of areas. When you made your first POD, I said, well, okay, it can be as worse as possible. However, then you have a starting point. You have a reference point. Then you can say, well, I have a new method which is even better than that. Okay, then introduce that. But when you have absolutely, let's say, no idea, then you can only say, well, I will buy this equipment because it is red, green, or blue.
Thank you. Now, in this particular example of automotive weld inspection, you were looking at welds of certain lengths, and I saw the A&A hat, and it took me a little while to realize that what is the implication of flipping the POD curve. How I was thinking Daniel is talking about false call and misses in the opposite quadrant, but having worked too many years on crack detection, I was lost there. But then I finally got it. The question is, in the case of weld inspection, what happens if you actually have a bound that weld should be minimum this length and maximum this length? So that if it is too long, we should be able to flag it as a bad weld also. So so in this curve, what does it mean? That there's another line, and now you have a 3x2 or a 3x3 matrix to define where that, was that a situation? Did Porsche ever define that this weld is too long and it's a bad weld if it's too long? No. Okay. All right. Thanks.
The whole point of this welding is if it has a specific size, so a connection between the two sheets of metal, which is at least the minimal diameter, then it will hold the stress. If it is the double the size, well, it will still hold the stress. However, if it gets smaller, then we might have an issue. And this idea of, on the one hand, it's bad, on the other hand, everything is good, this is great. And I think this kind of idea is not so easy transferable to other testing, let's say, issues or some testing problems. So for me, it was also quite challenging when I came out from crack detection. I said, okay, above my A detection, my decision threshold, these are the defects. And then I look there and said, oh no, there it's just turn around. However, I see it here more like when you normally, I think the most of us won't come into connection with too many PODs. You will kind of understand, learn how it is for your specific field. Then it will be kind of maybe even modified. We saw in the last few years a lot of modification of PODs. And then you will go accordingly. It is just only for a few people like you and me that we need to change our thinking around.
Oh, Daniel, let me tell you something. We may not realize how POD comes into everyday situation. I'll tell you, yesterday, my wife did grocery shopping and she brought jalapenos. She put it in the fridge, okay? This morning, I'm cooking breakfast. I'm making omelet and I want to put jalapeno. And I'm looking into the fridge and I cannot find the jalapeno jar. And I said, how is it possible? It has to be in the fridge. It cannot be anywhere else. I go back in and I check, and this time I scan very, very strongly and I find the jalapeno jar. Why did I miss it the first time? The first time I was looking for a short, stubby jar, but this was actually thin and tall. So I was missing it. This thing about go to the kitchen and open the drawer and you can't find the pizza cutter and your wife says, it is in the drawer. It's a probability of detection problem. We read the document and we miss the fine print, right? Because somebody has made it deliberately small that you cannot detect what they're hiding from you.
I agree.
Probability
However,
of detecting jalapenos.
If you have your omelet without jalapenos, I think this is one point. If you have a new car and you're missing 90% of those spot welds, well, I would prefer to have an omelet without jalapenos.
Now, Daniel, I also have a couple of questions.
Yes, please.
Perhaps until Ripi thinks of the next one. So my number one question is, so you had, or up to the moment, they were doing a manual testing of each and every spot weld with ultrasonics, I guess.
Well, of course, not of everyone, because we have 5,000 of them. So they have. Don't ask me about the.
So they did some sampling.
They have a sampling.
Yeah. How long did it take, nevertheless, to do that inspection? Okay. How long does it take now to do? But now with the new system, you're doing every spot, every weld.
No, also not every spot.
Okay. So same amount of spots of welds or different sampling?
No, more of them.
More of them.
So the interesting part, and this is quite a statistical kind of question, is when you are doing the sampling, then you have the possibility of having, for example, false alarms or misses or something like that. And you just think of, I sample a specific amount on that car, and I have a statistical kind of value if my sampling is really telling me the population of the whole car. Mm-hmm. This is something you can read in kind of every
statistics book.
Not statistics, but also in standards, like GUM, etc. So in this direction. However, when I was discussing with them the last time, like statistical people based or focused on sampling methods, I said, okay, and what about your capability of your testing system? And they were looking at me and I said, well, we have there a gap. I said, okay, I have there a solution. But this is the same kind of statistical idea. When you test more of them, let's say simplified, your testing system can be even a little bit worse, and you get the same result out of it.
So how many more do you test?
I can't even tell you that. I have like an amount of testing spots, and when you have, for example, here around 7,000, and when you just think of the manual testing, which takes you 30 seconds for one spot, you can kind of calculate it, how many people you need to have that. This is maybe not the direct answer because, as I said, I'm not sitting in Leipzig. This would be more a question for Nico, but I hope that gives you a clue about it.
So for this one here, for this real-time POD, I guess you need both measurements. You need the manual UT and the, so in future, once you would directly go to only doing automated LEA testing, then you would switch off that POD cockpit.
This is quite a statement. I can't look into the future in companies like Porsche. However, the topic about sampling is still existing all the time. So at the very first start, you will have both in parallel with a significant amount on the manual additionally. However, you also have different spots which will be in quality management for cutting open. You still have that, right?
So you have more or less three methods, and then you might be fading out somehow the manual after some time.
I think this kind of manual, if you want to be sure, you keep it for a specific area, and especially when you restart or when you start a new line, when you start a new chassis or a car body, when you start new processes, etc., you will have it very high and then lower it. And if you see that your POD is running in the wrong direction, you get it up again. So it is pretty much like it is again a sampling question. When you are quite confident about the automated system, let it run. Mm-hmm. And you still have the second line of, so this is at least how, in my way, I would do that, and how it is done right now. But to look into the future, I can't be 100% sure about it.
Last question, at least for the moment. Can you go one or two slides back to where you have the POD curves comparing? No, yeah, this one. Now, it could be that I'm doing a wrong interpretation on the data we are seeing, and perhaps also the factor of sampling size needs to be taken into account to do a real proper interpretation of those curves. But here it looks for me like what you call here imaging UT testing or manual UT testing, that one has a better POD than the LEA.
For that specific case, as I said, I choose that, yes. For that specific case, it is like this. However, 3 comments to it. First of all, these POD curves were done like kind of, let's say, in between the processes. So I think they came around with a new probe there even after that. However, it would be, for our understanding, it is also necessary that the imaging UT testing system for this case is better because we are using it as the standard method. If it would be the other way around, then the POD wouldn't show you how good the testing system, the automated testing system is, but how good your reference testing system is. So this was this specific case. In a few of them, the curves were very near to each other, but just as a visualization, we choose that one. So this is not for all parts, for all. This is only for the longitudinal beam. So one component. To discuss all the parts, we need a little bit more time.
So do you think at some point the LEA testing might be better than the manual testing?
That depends on a few things. Is there the potential? Maybe.
I guess it really depends on the detector and excitation technology used.
Just keep in mind that also the automated system we used, that is not so long on the market. You have improvements. The people are, but on both sides, they are doing a lot of research in the direction. When we try to find this, for example, in a normal UT testing system, is the manual operator of an ultrasonic probe, is he better than an automated system? Good question. That depends. I think when you give a human a very specific kind of testing system, and that here you have your probe, and now you have all the time you need, and just find that defect, just give me an idea. And he is going around and look and find different angles and whatever, then he might come with a really good result, which might be even better than a robot which is doing the same steps 15 times. However, when you have 7,000 welding spots, I have kind of the feeling that the robot, which is doing all the time the same, might come around a little bit better than a human, which might not even find his jalapenos in his fridge.
So I guess the manual testing you are describing here is not even a field or a in production line testing, but this was a lab testing.
No, that was you could see it on the last slide where you have the person. First, the robot was doing the stuff, and then you saw the guy with the equipment and doing like for specific ones. So it is kind of on the production floor, but as I said, from the amount of it is smaller.
And it is not the 30-second testing. It is the inspector taking the time he needs.
I think he probably, when he is doing the typical things, he doesn't need more than 30 seconds.
Okay.
So it is quite fast, but well, robot is right. Yeah. It's not getting tired so fast.
So Johannes, when we studied human factors 20 years ago, 25 years ago, we found out that not all human factors bring the POD down. There are human factors that move the POD up, right? People who have experience and then they have a hunch there is something here, they keep looking at it until they find it, right? So it's whether you do repetitive attempts or you have a bias or whatever, or it's your gut that tells you something is here and you're able to pick the signal which is hidden in the noise, right? So there are human factors that can actually drive the POD in the right direction, which in case of robotics will not happen. So
yeah, so a kind of perfect mixture of both might be quite interesting. But how to go there? How do you know how good the whole testing system is in the moment, and how do you improve it with additional human interaction? Well, this is one idea how you kind of go along with the POD. You first do it like with the automated system, and then say, okay, let's give the human the guide, and let's see what he will come around. So for me in this specific case, it was quite interesting that when we are talking with a lot of typical POD guys, they are from aviation, etc. They have a specific kind of idea what to do with it, what the A1995 will be, etc. But the idea itself is just we are using our understanding of physics and we are using statistics. And what we want is we want to have an idea of what is our testing system doing. And that is for a lot of fields, pretty much the same.
Ripi, any more questions?
I think we are at the top of the hour, so this topic we can go on and on and on forever. Maybe we'll pick it up again when we meet next week in Korea, and we can chat about it. Because Daniel, you talked about this as another offshoot of detection, and there are a dozen that we had come up with long ago. And there's one very interesting one that when you combine AI and generative AI, and you can look at documents and what you can use generative AI as a detection tool to detect stuff in the documents and deploy POD concepts in there. It's a very fascinating possibilities that come out of, but like Daniel, you have pushed the boundaries of how people conceive and perceive and deploy POD. I commend that. And if we continue to do that, the horizon, we can push the horizon as to what we can do with it. So good job. Thank you once again. Well-deserved award. I can see that now.
Thank you
Daniel,
very much.
any famous last words?
I was very happy to show you my results. I'm very happy about the questions, very that you see, yeah, that you get the idea of what we did, and I'm very happy that you came to the conclusion that that makes sense. So I am happy.
So thanks a lot for showing us your result. Thanks a lot for answering all our questions. And now it's time for all of you to ask questions. Write them down here in the comment section, and I will make sure that Daniel actually answers all of them. Daniel, you will be busy. So thanks to all of you for watching this video. Thanks for all of you to subscribing to this channel, to giving this video a like, and to writing a lot of comments. See you next time. Thank you and bye.
Thank you. Bye.